Okay, so today class, we're gonna finish today class with a few examples with RStudio, just to make sure that everybody knows how to open it and open a file, because next class we'll start to delve a little bit more into data structures and a few more complicated commands in R. So today I just wanna briefly review the basics. The reason why I'm using RStudio, well, basically RStudio is, R with a user interface rather than just the command line. But the reason why I'm using RStudio is because it's free, and I do believe in open software and in, making tools available for everybody, those who can afford it and those who cannot, and that's the reason why we're using this source. It's also pretty straightforward, okay? It's command line based, and so although I will be teaching some programming skills in next class, in principle you don't need those. And also there's a wide variety of different packages that are implemented on R that we will be using. I think that I've already said this, and this is very important, so let me say it again. The important thing in this course is not so much that you learn how to run packages in R to, do supervised or unsupervised learning, but rather that you learn the methods, how the methods work internally, what's the math behind the methods, okay? So that, if in 10 years another tool exists, you will still be able to run that tool because you know how the methods work and what's the meaning of different parameters for those methods, okay? And so again, my focus is going to be on the machine learning concepts, on the methodological concepts rather than on the language. And so it's completely possible that if you want to focus on using other tools like scikit-learn, pandas, or weka that use different languages, and you want to use those languages for your projects, that's also fine, okay? You can work on the code using Java or Python if you prefer to, and you will upload your code in that language. That's something that I accept, and that's perfectly valuable, okay? However, the examples that I'm going to be giving in class are in R. But again, this is something possible. So if you want to look for packages in another language because you're interested in doing that, that's also something that I accept, because again, the focus is on the methods, not on the language. Okay, in order to install RStudio, these are different links that I'm offering you here. I mean, the first one should work for everybody, and again, highly probably most of you will have already installed RStudio, but just in case, that's the link. So please, go for it and download it. I'm assuming that, you're gonna do that, and so I will continue. The first thing that I want to ask you to do is to basically go to, and under the resources you will see that there's a file called weather.csv. I want you to open it, and we're going to basically explore it, okay? And this is the weather file. So as you can see here, I mean, this is a CSV file. It's a comma separated value file. So in principle, it's a format in which each variable is separated by a comma, and then you have different lines, one line per data point. However, CSV files can be opened into different formats, and so what I've done here is that I've opened this CSV file with Excel. And what you can see here is that basically it's called a weather file. It's called weather.csv because it contains weather data for Australia. So you have on the first column you have dates, second columns you have locations. So we have here Canberra, which is a city in Australia, but we have the dataset had other cities. I'm just cutting it just for Canberra. And then we have other different variables that measure weather. So we have minimum temperature, maximum temperature, rainfall, evaporation, sunshine, wind speed, and so on. I mean, you can explore them here. Okay, and whether it's going to rain tomorrow, yes or no. So the objective of this file is not only collecting weather data, but also being able to predict whether it's going to rain tomorrow or not based on different features. We're not going to do any prediction today, but this is the file that we're going to be using. And so let me go back to the slides. As I was saying before, this is a CSV file, comma separate values file, and this is a pretty common format when we work in data science projects. So the objective of the next slides is basically to get a sense of the data set and to familiarize ourselves with R, or to remember R if you already know it. And so let me minimize these slides, and I have opened RStudio. If you haven't done so, please open RStudio. Okay, I have here RStudio. I mean, this is a console, this is a command line, but I also have here, in the user interface, I have here, in case we plot things, and so the environment is a little bit much more convoluted than just only R. And so the first thing that I recommend you to do, I mean, there are two commands, get working directory and set working directory, that basically tell you the directory where you are at. Okay, and so in my case, it's telling me that, the directory where I am at is users/Vanessa. This is important because, I mean, it's important to be well organized when you are writing code and when you are writing programs. And so, generally I like to keep sort of this one directory where I keep all of my exercises or the code that I generate, and so I have everything there. And so, if you want to sort of set what's the directory where you want to be working on and tell RStudio that that's the directory where you have all your code, that's something that you can do. And the command, as you can see on the slide, is called set working directory, right? And then you can basically write the place where you are telling, with this command, you are telling RStudio, go to this directory, okay, to this folder, which is like a folder. And basically, anytime I tell you to read a file, just assume that you have to find it in that directory. Okay, so in my case, I put everything under Vanessa, classes, inst 737, and then exercises. Okay. And so, the next time when now I'm going to be using the read CSV file. And so what I'm telling R is that all my files, all the files that I'm going to be reading are in this directory. So when I tell you to read this file, I don't need to write the whole directory name. Okay, I just can write the name of the file. Obviously, you can do the same thing. You don't need to set the working directory. Anytime you open a file, you can just specify the complete route, but I find it to be, more tedious, and so that's the reason why I do this. This is just personal preference. And so, now to read the file, there's a command in R, which is called read.csv, okay? And then you have to write the name of the file. In my case, is weather CSV, which is under the directory classes in 737X, okay? And so, we have already read the file, and so, what's the thing that we can do next? So, we can explore what variables we have. And so for that, we're going to be using the environment that RStudio provides us. Okay, so for example, what's the first thing that we can do? The general first command that we will always use is the view command. Okay, so view command basically allows you to explore the data similarly to the exploration that we did with the file, with the Excel when we were looking at the file, right? So if you look here at this table, and let me make it a little bit larger. So it's exactly the same file that we observed in Excel, right? It has the same columns with all the different weather features, location, date, and so on, okay? We can also run other commands. So for example, with this command, we can basically see, what are the different variables that we have there, what are the different features that we have there, okay? For example, this is telling us that we have, 24 different variables and 366 observations. In fact, if we scroll down here, our data set, we will see that we have 366 different entries, like different data points for the weather, right? And what this str command is telling us is basically, what are the different features that we have and what are the different values that those features are taking. Okay, and you see, we'll cover this next class, but the variables can be factors, can be numbers, can be integers, right? And so, that's something that again we'll cover in class number 2, but this string command is telling us, more information about it. And then also the dim command is a pretty well-known and used command as well. And it's just sort of like the shortest summary of the str command, and it just tells you the number of variables by number of observations. So we have 366 rows, which are observations, and 24 different variables, which are the columns. Okay. What else do we want to see? Let's see. We can also explore, different values for data. In our case, I mean the frame or the variable where we are saving all the information is called data. Okay, and so we can sort of explore specific rows. So, the way we do this is by using row numbers. So, I mean, the framework has different rows and different columns, right? And so, whenever we put these comma separated numbers, what they represent, the first value represents the row and the second value represents the columns. Okay, so what I'm saying with this command is to basically print the first 10 rows and all the columns, right? So what you see here, these are the first 10 rows and these are all the columns for the rows. If I only want to see a few of those columns, say for example that I only want to see the first 10 rows and the columns 3 to 6, this is what we are showing here, right? So remember, the first field within the parentheses is the number of lines that you want to see, and the second field are the columns that you want to see. Okay, we are referring to them by numbers, but we could also be referring to them by the name. Okay, so you could be doing something like show me the data for the first 10 lines for the rain tomorrow variable. Okay, and that would tell us, you know, for the first 10 lines, what's the value for this rain tomorrow, which is the last column. Okay, perfect. You can also check top and bottom values with the head and the tail commands. Okay, so this could be giving you, you know, the first values and the last values, like the first in the data frame that we have. And we can also check general statistics, right? So, for example, you know, there's the best command to do that is the summary command. So this summary command, what it's giving you, as you can see here, you know, what's the minimum value, what's the median, what's the mean, what's the first quartile, what's the third quartile, and what's the maximum value. Okay, and the number of NAs that you have in the field, because some NA means that it's not applicable. It means that, you know, you don't have values for you know, some rows, you don't have value for this specific variable. Okay, and so this is basically, you know, general statistics that you can retrieve for every single feature, and summary, you know, is the most comprehensive command that you can do or request. You can also check, you know, if you want to just check for specific things, like, you know, like in the slides you can see, you can just check for mean values. So for example, you know, if you want to check what's the mean value in the data set that they have for the minimum temperature. Okay, this is the mean value, minimum temperature. You can see here that it's this third column here. Okay, and so the mean value for mean temperature could be 7.2, and that value should also be here. If we scroll up, you know, for mean temperature, the mean is, as you can see here, 6.266, which is exactly this value. Okay, so these are just ways of, you know, sort of computing specific numbers within the large summary that you have there. You can also check, for example, for that mean temperature, you could also check what's the range of values that it takes, you know, from the minimum to the maximum, and you can see values here. Which should also be the same here. So it's -3 and 20. In fact, we have the minimum value -5.3 and the maximum value 20. Okay. Take the quantiles, and so you can see here that, you know, the values are exactly the ones. Let's look for another feature that we can see, for example, for data cloud 9 a.m. And so if we look at cloud 9 a.m. here, like in this column here, you will basically see that, you know, the first quantile here is 1, which is exactly the same value that we have here. And then we have, you know, the third quantile is 7, exactly the same value that we have here. Okay, so if you want to look at sort of general statistics, just use summary. If you want to look at specific things, there are different commands to do that. Then in terms of quantiles, I mean, for those of you who don't know it, basically, you know, the way we compute those is that we order data and then we divide it into Q equal size subsets, okay? And that's why we call them Q quantiles. And then the quantiles are basically, the number for the quantile is the value at that boundary, okay? So for example, the 2 quantile is the median, okay? And it's basically, you know, that value that separates these 2 consecutive subsets. So for example, continuing with quantiles, okay, if you want to go back to, you know, checking the data for the mean temperature column, the way we compute those quantiles is that we first sort the data, okay, and then basically we can check, you know, what's the first value, what's the value at the 25%, 50%, 75%, and 100%. Okay, so what I'm showing you here is just an example of how the quantiles are computed. So you can basically, go through this code and try and figure out how those quantiles are computed. We can do that together if you want. Let's do it together. So if we take the data for the minimum temperature, okay, we sort it. We have it here sorted, and then we save it in another variable so that we can manipulate it easier. So what we are saving in this variable is just this huge matrix that you are seeing there. If we look at the quantile for data mean temperature, okay, the 25% of the values is value number 91, and as I was saying before, value 91 is 2.3, which is here, okay, so it's exactly 25%. Value at the 50%, if you order the samples, the 50% of the samples, half of the samples is value number 183, okay, and value 183 is basically 745, which is this 7.4. That's the value 183, and it's exactly this 50%. If you want to look at the third quantile, which is the number that's at the 75th% of all the points that we have, that could be the point at the position 274, which is exactly here, 274, 12.5, which is exactly the third quantile. And then the fourth quantile is just the last number in your series, which in our case is 20.9, which is exactly this value here. Okay, so again, this is just an example of how quantiles are actually located. You don't need to do this. You just run the command quantile and you get those values. But the way those values are obtained is basically by sorting the numbers that you have and then identifying values at 0, 25%, 50%, 70%, 55%, and 100% of the values that you have. Okay. Okay, in class number 2, I'm going to go in depth into ggplot, which is a really good, very good command that we can use in RStudio and R to plot, to do beautiful plots. However, there's some simpler commands that R has to do very basic representations, and so those are table, pie, and bar plot, which represent, as you can imagine, data in tables, pies, or bar plots. Okay, and you can represent both categoric variables, like the direction of the wind, which could be east, west, south, but you can also represent numeric variables. And so for numeric variables, we have histograms and plots. Okay, and I'm going to show you these very basic commands, how they work within the framework of these weather data. So, for example, if we represent on a table the data for one of the categorical variables that we have, for example, wind dust, what this is telling us is that basically, these are the different values that we have. So, we have 37 values where the wind direction is east. We have 30 values with the wind direction is east, northeast, and so on. Okay, so that's the way we can interpret this data. You can also represent it in a pie type representation. So if we take, that table and take the wind gas direction, okay, and we represent it in a pie, we can sort of look at this same data but in a more of a visual representation. And so what you can see here is that the largest number that we have is northwest, where we have 73 samples, and you can see here how northwest, it's also quite big in this pie. You can obviously also represent bar plots. So if instead of pie we write here bar plot, this is another command that basically represents for each of the labels that we have for direction, wind direction, we can represent how many samples we have. And so if instead of these categoric variables we want to work with numeric variables, then we have both histogram and plotting commands. So we can represent histogram for something like like the mean temperature. So we can sort of look at the histogram and see, okay, so how many, or what's the frequency for each of these temperatures that we have on the x-axis. Okay, so x-axis representing the minimum temperature, y-axis the frequency of that value within our data set. But we can also basically plot that information as well. So we can use mean temp this plot, and what we represent basically, rather than a histogram, we can represent the density of the data, okay, which again, it's, what's the distribution of those values, and we can see that, the values go from, between 0 and 20, okay, with certain peaks. So that's another way of representing numeric variables, with either, a histogram or plotting, the density of the information. Okay, and then the last thing that I'm going to talk about today about plotting is the command with, which basically allows us to combine two different data sets and see how, one data set might be related to another. The reason why this is important, okay, so this is important because generally when we are working with data sets, one of the first things we want to look at is basically how the data relates to each other. Like, for example, if we want to look at the relationship between temperature and the direction of the wind, okay, and imagine that we want to predict, whether it's going to rain or not, the first thing is to observe the relationship between any variable and rain. Or the first thing is to observe if two variables are correlated or not. The first thing is to plot them and see whether there's a correlation or not. And so this command is a very easy way of trying to understand whether two specific variables are related to each other. Okay, and just you have here multiple examples. I'm just gonna run one so that you can see it, or a couple of them maybe. So you can use data and basically plot or try and understand the relationship between the minimum temperature and the sunshine, for example, and let's see if they are related. And so if we look at this plot, do you find any type of relationship? Well, I would say hardly, right? I mean, I see that there's data points all over the place, so the minimum temperature doesn't appear to be very correlated to sunshine. However, if on the other hand we explore, the relationship between something more obvious like the minimum temperature and maximum temperature, do you think that they will be correlated? Well, highly probably, right? I mean, if we look at, how these two relate to each other, we can see that on a given day, if the minimum temperature is lower, the maximum temperature is also going to be lower. If the minimum temperature is higher, the maximum temperature is also going to be higher. This is sort of, a linear relationship that we are seeing here. And so, as I was saying before, this with command is a very easy, straightforward way of analyzing, doing a very first simple analysis of relationships between variables. Okay. Class, I hope that it's been, a good introduction to the course and to what we are going to be doing over this semester. And next week on our second class, we'll be talking about managing and understanding data, mostly, on, working with more complicated things using data sets in R. And after that, we'll look into probabilities, and then we'll start with supervised and unsupervised methods. But again, very important, remember to form teams by next week, and remember to start thinking about the research questions that you would like to answer. And that's it. Thank you very much, and I hope to talk to you next week.